Welcome back to another exciting chemistry lessons. In the previous lesson, you learned how to make compound, specifically ionic compound, from oppositely charged ions, that is, positive ions and negative ions. Now in this lesson, we are going to learn how to name the compounds. Well, the steps is very easy. Again, you are going to use the name of the positive and negative ions. And you already memorized that already, or at least they are given to you on the periodic table, and they are given to you as a list of polyatomic ions. And if you remember this correctly, the name of the positive ions is just the name of the element. Except for if you have elements in group B's, some of them have more than one charge. You have to use the Roman numerals to represent the specific charge. For example, if I were to look at copper, copper could have 2+, it could have 1+. So if this is the case, we are going to have copper, in this case, what's the Roman numeral for 2? Just I. What about what's the Roman numeral for 1? For copper with a charge of 1+, just I. So that is the only thing that's tricky. And the only thing that's tricky is the negative ions, because the negative ions has a unique name that ends with IDE. So keep that in mind. So let's start doing an example problem. Here we have aluminum right here, right? This is the positive. We know when we make this compound, the positive ions always first. So this is just aluminum, because aluminum is in group what? Aluminum is in group 3A, going back to your periodic table. So this is just aluminum. Boom, that's it. What about O3? Well, O3 is coming from the oxygen. See how the oxygen right here? This is from oxide. There you go. So we have aluminum oxide. So the 3 here doesn't dictate what's the name's going to be. It is the element symbols that tell you the name of the ions. Now let's try the next problem. Here we have NH4+, and we know this is a polyatomic ion, so we have to go over here, look for NH4+, which is ammonium. So we just have the name ammonium. Isn't that easy? And then what about S? Well, S is your negative ions, and it is not a polyatomic ions, and we find S is right here. That is your sulfide. So it's ammonium sulfide. And that's what we meant by using the name of the positive and the negative ions. Let's try another one. Here we have copper chloride. So copper, remember, is in group B. So if we look at coppers, it's in group B. So we don't know if it has a +2, +1, or +3. But this chloride right here, chloride has a minus. And we know if this is a minus, copper must be a positive because the total needs to be equal to 0. So in this case, we know that this copper is a copper of Cu+, which we use the Roman numeral. And then for Cl would be chloride for the name of the negative ions. So that's how you name elements from group B with more than one charges. Let's try another problem. Here we have Na, and Na is sodium. That is in group 1A on the periodic table. And OH right here, that's a little bit tricky because we don't have the parentheses there. But OH represent what? If you go down to your list, OH represent hydroxide. So we just have sodium hydroxide. That's all it is. Let's try another one. Here we have Ca, and we all know that Ca is in group 2A. And Ca is calcium. And if you don't know that calcium is in group 2A, look at your periodic table. What about NO3? NO3 is your polyatomic ions that's grouped by this parentheses right there, which in this case we know that it is what? Is a nitrate. So we have calcium nitrate. And notice how this 2 doesn't have any impact on the name. Then let's try the last one. We have Cr, which is chromium. Chromium is a elements on group B. So we have chromium, but what's the charge for chromium? We don't really know, but we know oxygen has a 2-, and how many oxygen do we have? Just 1, so it's 2-. This chromium must be 2+. because 2 plus and 2 minus equal to 0. So we have chromium, okay, and what's the Roman numeral for 2? Just II. And lastly, oxygen will be just chromium oxide. And that is how you name an ionic compound using your periodic table and what you already know about the naming of negative ions, as well as the list of polyatomic ions. And that's the reason why you need to be familiar with the name of the polyatomic ions before you can actually name any ionic compound.